Hi everybody, this video is the review video for those of you who are gone on Thursday, September 19th. Okay, so before the bell, I had everybody take out their Investigating Landforms on Venus articles, and I wanted them to take a picture of the front page and then put this in their GOM 2.1 notes so it looks just like that, okay? We'll talk about that more in a second. So go ahead and do that and then come on back and keep playing the video. All right, second thing I want to show you is you probably already noticed, but I want to explain it to you. In today's folder, you will see a copy of your GOM vocabulary and key concept tests. The vocabulary and key concept test is a week from today, Thursday, September 26th. This is exactly what you will get 1 week from today. Use this to study your vocab and your key concepts, okay? The front page and a little bit on the back are all of the vocabulary terms I'm going to ask you. And then you'll see on the back, I've got all 5 key concepts, and I actually started the first 2 words. I included the first 2 words of the key concept for you. And so that might help you to study as well. If you do not do well on this test, I don't know what to tell you. It comes down to you have to force yourself, make it worth something to you to study. I'm giving you everything that I can give you. You need to do the last little bit and study. Okay, let's go ahead and get started. So we're on lesson 2.2, modeling a geologic process. I want to talk about that article. So everybody had that out on their desk. And I want you to include, we just spent some time talking about, so what was the big idea? Why did we read that article? What was the whole point behind it? And it was interesting to find out about different landforms on Venus, but we're talking about a landform on Mars. We're trying to figure out what formed the channel on Mars. So I didn't have you read this so that you could learn about another landform that has nothing to do with what we're doing in class. The reason for reading the article was so that you could see how a scientist uses models to get evidence when there's no way you could get evidence by going to the planet. You just couldn't do it. It's too far away. So go ahead and next to where you put your picture in your notes, go ahead and write big idea. And the big idea is models can provide us with evidence. I'm going to have you go ahead and write in a vocabulary term in your notes, and I'm not going to show you how it should be until a little bit later. By now you guys should know that if you have a vocabulary term, it goes on the left side. You're going to highlight it in green. And the definition of a model is an object, diagram, or computer program that helps us understand something by making it simpler or easier to see. Go ahead and pause the video and then start it again when you're ready. So we talked about Garia. He was the scientist from the article, and he had a question. His question was, how were the novae on Venus formed? So in science, we always start with a question. And then you can kind of, based on, previous knowledge or just your educated guess, he came up with 2 reasons why novae were on Venus, but not on Earth. The first reason was because Venus has a higher surface temperature than Earth. If you remember, it was like 862 degrees Fahrenheit, super, super hot. And then he said the second reason why novae were on Venus, but not on Earth, is because Venus has a thinner crust. And he kind of went on to explain in his thinking. He's like, listen, if it's so hot, then that means, the surface temperature, that rock that's on the surface temperature, it's weaker, it's softer, it's kind of like tar-ish, so it's kind of a soft outer solid layer, if you will. And because that's so soft, it would be easier to kind of give way. And so then as the magma comes up and pushes up against the surface, that surface just sort of bubbles up, and it's easy to form this novae. So he had a hypothesis, and I'm going to show you this again. His two reasonings, that Venus had a higher surface temperature and that it had a thinner crust, end up being part of his hypothesis. And a hypothesis is when we make an educated guess that we're going to test. So his hypothesis was the higher surface temperature and thinner crust might have caused the novae to form. So how did he test his hypothesis? Well, he organized a computer simulation. He created a model. So he set up his model based on his hypothesis. And remember, the hypothesis included those two parts. Number one, high surface temperature. Number two, thin crust. And when he ran his tests, before he ran it, he realized that if the end result in his model, in the computer model, if what he ended up with looked exactly like what he saw on Venus, the real novae, then he knew that evidence for his model, he could use that to support his hypothesis. So that's what I'm saying. Sorry, I forgot to do that. So remember, the hypothesis was the higher surface temperature and thinner crust might have caused the novae to form. So did the model give evidence that supported or refuted Garia's hypothesis? Well, it turned out that his computer model looked exactly like the novae that were on Venus. And so those shapes were really similar to the real ones, which meant that it provided the evidence that supported his hypothesis. In other words, he could use the model as evidence. Now, if that model did not show anything and it didn't look anything like what was on Venus, then obviously he couldn't use that to support his hypothesis. It actually refuted or argued against his hypothesis. So the bottom line is models are really, really useful for us when we're trying to answer an investigation question. So this is key concept number 3. I'm going to have you add this to your notes. Remember, you're going to write KC3 on the left side and then kind of a little cloud around KC3. And then the actual key concept is scientists can use models to test their ideas and get evidence. And this is what you should have then. There's the model definition. And then KC3, remember, anytime we have key concepts, we're going to put little clouds around those. And that's what we've got. Go ahead and pause the video until you've got everything written. Okay, so now I think that we need to learn from Garia. He wanted evidence about the geologic process that formed the novae on Venus. We have a similar question in that we want to know what geologic process formed the channel on Mars. And remember, there are two different claims. The first claim says that flowing water formed the channel on Mars. And the second claim says flowing lava formed the channel on Mars. So we need to use models to test each claim, but because they're using two different geologic processes, we have to create two different models. We have to test them using the models one at a time. So let's go ahead and start with claim 1, the flowing water formed the channel on Mars. Great. Now what? What are we going to do to model this? How are we going to do it? I don't have the information or the time or whatever to have you guys use coding to make your own computer model. That's not going to work. We need some kind of a physical model, some kind of a hands-on, some kind of something that we can see, okay? So let's start breaking down this process of how do we use the best model to answer our question or to test our claim that flowing water formed the channel on Mars. Okay, so if you remember, Garia's model looked like a real novae, right? So Key concept 2 says when landforms on different rocky planets look similar, it's evidence that they may have been formed by the same geologic process. So, if we pour liquid water on something that represents Mars's geosphere, and the results look like a channel, then we could say that we could use our model as evidence to support claim number 1. Okay, so great. What can we use to represent the surface of Mars? I've got real water in my classroom. We're going to use that. But what can we use to represent the surface of Mars? Well, some kids in class said, well, why don't we just use rock? Well, that's a great idea, except not really. Because here's the thing. I only have you guys for 47 minutes. And if I poured water on rock, it would take a lot longer than 47 minutes for you to see any kind of change in the geosphere. So the kids were talking and talking and talking and offering ideas and suggestions. And we came up with this idea that we think sand would be the best representation of the surface of Mars, because some of the kids had previous knowledge that when you pour water over sand, it moves. And that's really what we're looking for. We're looking for something that would move if water was poured on top of it. We want to see we want to fast forward that whole geologic process to see what would happen. So I wanted the kids to take a minute and figure out how to set up our model so that we can test it. We're going to test it on Friday. So they got with their table partners, and I gave them a piece of paper, and I said, show me what I need. Tell me how to set this up. What are you going to put the sand in? What are you going to put the water in? How are you going to get the water in the sand? How are you going to make it so that it's a channel and not just a big puddle? So we went through all of these things, and the kids were drawing, and I let them just go for the rest of class. And tomorrow, on Friday, we're going to evaluate these, and then we're going to set it up. Okay? Remember that your key concept and your vocabulary test is next Thursday. Please, please, please take advantage of that test that I have and start studying. Okay? All right. I will see you hopefully tomorrow.